and I'm going to show you how to do aeration with GIF mod, right? So, okay, let me do this. So this is my GIF mod window. I'm going to show you how to model, you know, BOD consumption and aeration at the same time. Okay, so basically the first thing is that just like always, I just add a pond. I consider my kind of open system to the atmosphere to be represented by a pond. I'm gonna just make, you know, let's do this bottom area 1, initial water depth 1. So that's, so I have this container that is 1 cubic meters. I mean, it doesn't really matter, but it's just make it standard. And then, so that's all they have. Now, I'm gonna add 2 constituents, okay? I'm gonna add 2 water quality constituents. One of them is going to be my BOD, and the other one is going to be my DO, dissolved oxygen, okay? Then I'm gonna have, so then I'm gonna define my reactions. So basically, first let's add reaction parameters. So the reaction parameters are, one of them is K sub D, right? Which I'm going to assign a value of let's say 3. Okay, that's my BOD decay rate, right? BOD biodegradation rate. Call this K underscore D. I mean, it doesn't make any difference. Then I'm going to add, I need another parameter too, and that's the re-aeration rate. Now I'm going to just use some arbitrary numbers. Hopefully things will work out fine. If not, I'm going to come back and, you know, change them to get some more interesting results. So basically I'm going to say, so K sub A is the re-aeration rate. Oops, do I really need that? No, I don't need it here. I'm sorry. I don't need it because I'm going to introduce the re-aeration differently. So, so now I can just go and define my reaction network. I'll tell you how to do, how to add the re-aeration later on, because it's kind of a different way. So I'm just gonna add this reaction network. The process is, let's say, BOD mineralization, right? What I know is that the process rate is K sub D times BOD, right? It's a first order decay. And then the stoichiometric constant for BOD is -1. For DO is also -1, right? So we use DO, the same amount of BOD, and then we are mineralizing BOD, right? Then, okay, so that's that. And then what I want is that I want to add an external flux. I want to say, hey, we are receiving oxygen from the atmosphere, right? So basically that's done by this thing called external fluxes. So I right click on external flux, just add, I don't know, I can call this aeration, okay? Then, so there's a coefficient. Hopefully this will work. So the constituent, first of all, I have to say, I'm talking about DO, okay? So this, I mean, GIF mod doesn't know what is what, right? So DO, I have to say DO is what comes from the atmosphere, right? Then I'm just gonna do the model. So that here I'm gonna do a constant rate model, but as you can see, you know, there's free surface model and a constant influx. Those are different things. But free surface uses some of those equations, empirical equations that depend on, I don't know, depth and velocity of water and so on. Now here we don't have any velocity, right? So we can't use any of those equations. So I'm gonna use a constant rate, and then I'm gonna say my coefficient is, let's say, 0.4 per day, and that's my K sub A. Right, so K sub A. You know what? Let's make it. Let's make it like this. I'm gonna make it 0.2. I will see. I'm just making up numbers. I don't know how things are gonna work out. But so this is our K sub A. So that's why I didn't have to introduce K sub A in the reaction parameters. So that's what we have now. Let's see. And then one more thing, I have to apply this in external flux to this pond. Okay, I have to say apply that to this pond. So in order to do that, you know, you have this external flux. I can just pick aeration, right? So aeration is the one that I defined, the external flux that I just defined. Now I can attribute that to this pond. Okay. Now what do you think if I run it right now? So let's see. I'm just gonna save this as, I don't know, let's call it aeration example. Okay, let's run it, right? It's pretty quick. You know what? I probably have to run it for a longer period of time to get some meaningful, oops. Oh, something. You know, when I do aeration, I forgot something. There's this thing called saturation, right? That's a saturation concentration we talked about. I forgot to enter that. If I forgot it, it assumes that it's 0. So I'm going to use 8.5 as we talked about, or maybe 8.66, right? So that's the saturation concentration of dissolved, this oxygen in water. Okay. So now I'm going to do, I'm going to also, you know, make sure that I run it for a longer period of time. So let's say for 5 days. Okay. Then let's do it. Now let's look at what? DO. So that's what we get. You know what? I'm going to make it a little faster. So basically this, anyways, oxygen is going up. We haven't, now what's happening? We didn't see this, this curve that things go down and then go back up. Let me do this. I'm going to change I'm going to go to aeration and make it a little faster. So let's say I'm mixing my water and it receives more oxygen. So I make it 0.5 and then go. Okay, so now if I look at the oxygen concentration, it's going up and it's getting to this, getting kind of close to this 8.66. I mean, it's still not at 8, but anyways, it started from 0 because I haven't applied any initial condition to oxygen. So oxygen concentration initially was 0. And then I don't have any initial condition for BOD too. So this is like you have a clean water with no oxygen, you put it there, and that's a quiz that I gave you, right? It's the quiz that I gave you. This is what the solution to it is, right? Now let's now add some BOD to the water. Okay, so I go to here and then let's do constant initial concentration. So let's say the BOD, let's say we had an initial value of, I don't know, maybe 6 milligrams per liter. I want to make sure that I will not run out of oxygen. Or I don't know, maybe I can do 7. Then DO, let's also apply some DO. Let's say initially our water was saturated, so we had an 8.5, a little less than saturation, okay? And then now let's run it. So let's look at now what BOD is exponentially decreasing. Let's see what happens to DO. This is what we see, right? So it goes up, it goes back down. Now I gotta probably, it'll be more interesting if I just arbitrarily came up with these, you know, kind of numbers and so on, so that some of them may not be realistic. But so what I'm gonna do is that let's just run it for, I don't know, maybe 20 days, right? To make sure everything will go back up to, you know, kind of, or everything will sort of be finished. Okay, so basically that's what I do. Now let's look at BOD exponentially decaying, going almost to 0. Then DO, this is what we're gonna get. Copy, paste it here, and that's what we get. So oxygen goes down and then goes back up to our saturation level. Does that make sense? Any questions? Okay, so let me stop